Hello students. So today we are going to see the PYQ recent question papers on this topic, laws of motion, right? In January session those questions which have come. So here I have prepared the solution and let us quickly discuss this. So consider a block and trolley. So this is the diagram, this is one block, this is a trolley basically, and a block is here, okay, and the masses are given 20 kg and 6 kg, and the weight is also drawn here. It's sometimes you may confuse that what is this 60 Newton. This is the weight of this body, this is not external force, okay, here acting. So now if you consider the coefficient of friction is also given of this surface, right? Acceleration of the system they are asking. So draw the free body diagram. You draw the free body diagram of this block. So you can see the forces acting on this. First of all, normal will balance mg, right? Tension is acting opposite of friction, right? And if you see the forces on the block, tension is acting upward, right? Tension is a pulling force. So this is how tension acts, and its weight 60 Newton, right? So write the Newton's laws, right? Second law, net force is mass into acceleration. So if you see here, tension, it is going downward, means towards right side, so tension is greater, so tension minus friction is equal to mass into acceleration. First equation, right? Similarly you write this is going downward, so 60 minus tension is mass into acceleration. Mass is 6 here. Now you just add them. What do you get? 60 minus f, right, is 26a. Friction you have to substitute, calculate friction separately. Mu times normal, normal is equal to mg, that means it is the weight of this trolley. So just substitute here, values are given. Friction you calculated 8 Newton, substitute friction here, right? Calculate acceleration, which will be 2 meter per second square. So correct option will be option 3, right? Let's go to the next. Okay, next question. This is the example of a cricket ball. The similar examples, every time such questions are coming. This ball is moving, right, and a person is going to catch it with his hand. So mass of the ball is given, speed of the ball is given. After catching, the ball stops, final speed is 0, time is given 0.1 second, it stops, right? They are asking how much force is exerted on the hand of the player. So acceleration is v minus u by t. Calculate final velocity 0, initial velocity 25, right, and substitute. So acceleration you will get, right, this is the acceleration you will get, minus 250. Acceleration is minus, that means force is in opposite direction, or acceleration is in opposite direction for the ball. Okay, so first calculate force is mass into acceleration. This is the force on the ball, minus 30. The force acting on the hand of the person is in this direction, right? These are like action and reaction forces. So this is plus 30. So the correct answer is option 4, right? Let's go to the next. Next question, body of mass 4 kg expression. So forces are given, but it is given in terms of vector. They are asking acceleration of the body. So acceleration is net force by mass. Remember, this is net force. So two forces are given. Add both the forces. Both the forces are in terms of vectors. Club together I, j, k components, and then divide by 4, which is the mass. You will get this, right? That's the option 3, 2i cap plus a cap plus k cap, right? Let's go to the next question. Okay, let's go to the next question. Next question is saying that a train is moving with a speed of the train is given, right? And this rail distance between the rails is given. So let's say this is the rail, and the distance between the rail is 1.5 meter, right? And it is going with a speed is also given. Radius of curvature, that means it is going to take a turn like this, okay? It is going to take a turn. So radius of curvature is given, and height, they are asking the height. At what height we should raise this other side. So both the rail track is not flat. Rail track you have to make some inclination. This is the angle of banking, theta, right? What is that angle they are asking? So for this directly you may write this formula, tan theta is v square by g. If you remember, otherwise you can simply understand the forces. Normal is acting like this, mg is like that. Only force that should act towards the center, that is the net force. It is centripetal force, right? This is the net force. Now if you see, we need to resolve normal. Normal becomes this side, normal cos theta, normal sin theta, mg. So vertically it has to be balanced. That's why normal cos theta balances mg. Normal sine theta is the net force, which is the centripetal force here, which is mv square by r. So take the ratio sine by cos, that's how you derive this result. Tan theta is v square by gr. Now here in this triangle, tan theta is y by x. So y by x is v square by gr. Now you need to substitute here and calculate y from here. It is v square by gr into x. So substitute the values. All the values are given. Simplify this, and in terms of centimeter the answers are given. So bring in terms of centimeter 5.4 centimeter. That's the correct answer, right? So in this way you can solve the question. It is better to remember this tan theta equal to v square by gr formula. Let's go to the next question. A body of mass 1000 kg, mass is given. It is moving horizontally with 6 meters per second. Extra mass to be added. What will be the final velocity? So suppose momentum is there. So momentum has to be constant because you are adding the mass. You are not applying any external force. So net momentum will remain same. So initial momentum mass into velocity. Final mass is extra 200, right? So this is the final mass into the final velocity. So from here you calculate v 6000 by 1200, that will be 5 meters per second, right? Then let us go to the next question. Next question is a reasoning based question. They are saying that the limiting force of static friction. Limiting force of static friction means maximum static friction. Maximum static friction is mu s into normal. That depends on area. First of all, you should know friction does not depend on area. So first statement itself is wrong. And kinetic friction, which you know, mu k into normal, right? This also doesn't depend on the area. The limiting force of kinetic friction. Limiting force, of course, this statement limiting force of kinetic friction means this is the kinetic friction only, is independent of the area of contact and depends on material. So of course it is independent of contact area and it depends. So on what factors friction depends? So you can see according to the law of friction, friction depends on what? Mu and normal. Mu depends on nature of surface, nature of the contact surface, like two different materials, right? And normal contact force means the contact that is happening between them, and it will depend on the mass of the object, of course, right? So second statement is definitely true. It depends on the independent of the area of contact and depends on material. That's right. So we can say the second statement is true. First statement is false, right? First is incorrect, second is correct. Okay. Next. Let's go to the next question. Now, what is the next question? A heavy iron bar of weight. There is a heavy iron bar, like we can see here. This is an iron bar. This iron bar is being supported. One is at the ground, another is a person is holding it using his shoulder, right? The rod makes 60 degrees. This angle is also given, how much it is making with horizontal. The weight experience. See, weight experienced by the man is he is experiencing the normal. Why? Because he is applying the normal force to this rod. Same normal force will also act on the man. Okay, we have not drawn the free body diagram of the man because that is not important. Here we have to study the rod. Okay, so here you can consider the equilibrium of the rod. So net torque on the rod is 0. So torque is created by this normal. This torque will make it rotate in this direction anti-clockwise, and its weight will try to make it rotate clockwise. Both the torque of the weight and torque due to the man, you balance the torque. About this point you have balancing. So this is the now n force into this distance L, right? That is what is torque. Force into perpendicular distance. Here this is the force, weight which is acting. Perpendicular distance is this. So how will you calculate this? Because this distance is L by 2, because the weight is acting at the center of mass, right? So this total length of the rod is L. So half of the length is L by 2. L by 2 cos 60 degree, L by 4, right? Once you get this, so mg into L by 4 you do, and from here normal you get as mg by 4. So normal mg by 4, mass is 12 kg. Substitute, you will get from here 3g. G is given or take as 10. So anyway, they are not asking to calculate the force, they are asking the weight. Of course, weight in common language, weight means mass, effective mass. So here 3g, when you calculated it, divide by g, you will get 3 kg. So that will be the answer. Okay. Then let us move to the next. Next is stone of 900 gram. So there is a stone, their mass is given, right, and a string is there and it is tight and it is rotated in a circular motion. Of course, this is a vertical circular motion. So they are asking tension. They have given omega. Omega is equal to 2.2 frequency. Frequency they have given RPM, 10 RPM. Convert that 10 by 60 in RPS and then use this omega equal to 2.5 frequency to calculate this radian per second. Radius is the length, which is 1 meter. So here you need to draw the free body diagram. You can see tension acting upward. So tension minus mg. Tension minus mg net towards force towards the center is called centripetal force, m omega square r. We can use also mv square by r, but if they have given speed, then we can think of that. But here omega frequency they have given, so we are using this. Okay. So from here tension is mg plus omega square r. So just substitute the values and simplify. So this question will require simplification. Little bit simplification you will do. And they have given the value of pi square in the question as 9.8. 9.8 you have to take common and simplify. It will come as 9.8. Okay. So depend on the given condition the question. You have to simplify according to that. Okay. Sometimes pi square is taken as 10. So according to that we can do. Okay. Let's move. Next question. So here they have given two blocks are there hanging like this. Okay. There is a pulley. A string is passing like this. This angle is 30 degree. We have to find acceleration of the block 2 kg. That means this. So suppose this is acceleration A1. This acceleration A2. Both accelerations are not going to be same. So we need to first get relation between the acceleration. You can use constant motion, but instead of that it will take more time. So use this concept that tension into acceleration. Product of tension into acceleration plus here also tension into acceleration. All those product has to be 0 because work done by this tension is like internal force. So on the system, internal force does not do any work. Okay. So this tension into this acceleration A2, right? Here tension is 2t and acceleration is A1. Of course here A1, A2 are in terms of factor. Okay. But you know they are actually it's a dot product. So what it is? It's like dot product. Acceleration and tension because both are factor quantities. So this is like in terms of factor. But if you take dot product, this tension 2t and this acceleration opposite, so you may write minus sign here itself. Okay. But if I am not writing that minus sign, so minus sign coming here, that is direction, right? So here magnitude wise you can write as 2e1. E2 is equal to 2e1. Once you write it, then you can just write free body diagram here. So if you see here, this is 4g, weight minus 2t, tension is mass into acceleration. One equation you got it, right? Then here tension and this component of weight, this direction is mg sine theta, right? That is opposite. So this is equal to mass into acceleration. Substitute and simplify. You will get this. Further solve these two, right? You need to solve these two. So these two equations which you got, you just multiply second so that you want to cancel tension, right? So 2 times you multiply and then add, you will get acceleration A1 as g by 6. A2 they are asking, which is 2 times A1, that will come g by 3. Okay. So in this way you can solve this. The correct answer will be g by 3, second option. Okay. Then let's go to the next question. Next question here is block of mass and this block is kept here. It is pushed by some force 10 Newton. Angle of inclination 60 degree. Okay, and it is pushed 10 meter along this inclined plane. Work done against friction. So first of all you should note work done against friction means it is negative of work done by friction. So work done by friction we have to calculate. Work done by friction is as it is going up 10 meter, friction is acting backwards. So minus F into displacement, right? So this is the work done by friction. Now here friction force we should know. To calculate friction, this is mu times normal. Mu is given, normal is mg cos 60 degrees. Substitute, you got 0.5. Substitute here friction minus, so this will come minus 5 joule. Now you have to take here, substitute here, minus of minus 5 will become plus 5. So the correct answer will be option 2, right? Then let's go to the next. Next question in saying that block of mass m is placed. See, this type of questions in JEE Main already has come previous years. Okay, this has been like repeated questions. Nowadays they are repeating also many questions. Okay, having vertical cross section, this is the cross section, and coefficient of friction is 0.5 on this surface. The maximum height above. To solve this question very fast, they are saying at one height it will not slide. If you keep here it will start sliding. So if you go beyond this height it will slide. Within this height it will not slide. This is the maximum height. If you keep little bit higher it will start sliding. Before that it is stationary. Okay, so this is the maximum point where it is in equilibrium. Remember the concept of angle of repose. So if you remember angle of repose is that angle, you know, theta, where it is in equilibrium. So tan theta is equal to mu at that place. So tan theta is mu, and remember tan theta here is also the slope of this graph dy by dx. So this is the key idea here. Dy by dx is equal to mu. So once you put dy by dx, y equation is given. Then from here you will get x is 2 mu, mu is 0.5. Once you get x is equal to 1, y is x squared by 4. So x is 1, you substitute, you get 1 by 4. So similar model questions are being repeated. You can see that. Okay, these things are important. You need to pay attention that some of the models are being repeated, right? So solving previous year question is a must. Okay, next let's go to the next. 3 blocks A, B, C are pulled like this. So this is connected body, example of connected body. So for such type of questions we need to first get acceleration of the each of the body, or system acceleration is the net force on system by total mass. To total force is 80, total mass is 5 plus 3 plus 2, right? This will become 10. So 8 by 10 will give 8. Now you can see individually this body. So this body, if you see 5 kg, here tension is the only force which is acting. Vertically we are not seeing, because vertically it is balanced. So this tension is equal to mass into acceleration. All the objects will have same acceleration. They are connected simply. So here T1 is equal to mass into acceleration. 5 into 8, 5 into 8, 40. Now if you want to calculate T2, don't try to study this block or this block unnecessarily. It will take time to do fast. What you can do, you combine both these block you combine. If you combine 5 plus 3 together, then this is the tension T2 which is pulling it, right? So 5 plus 3 will become 8. So acceleration is same. T2 is equal to mass into acceleration. 8 into 8, 64. Just within few seconds you will get the answer. Okay, otherwise if you solve the question it will take more time. Let's go to the next question. Here next question is that there is a block capital M, small m connected by a string, right? The angles of inclination is given, and they are saying that what will be the value of this small mass if they are accelerating with a given acceleration. So first of all, draw the forces. Normal, mg cos theta, mg sin theta. Here angles are different, right? And as it is going this direction, friction is acting this direction. Let's say this is friction F1. On this block, again same way, it is going down, friction F2 will act upward. Tension is the same, right? Masses are different, so components of weight mg cos theta, sin theta may be different. Normal also will be different. Okay, once you draw this, then friction calculate. First you calculate friction. Friction is mu times normal. Normal here will be different, right? Normals are different, mu g cos theta only, but mass and theta is different. So substitute here, calculate frictions at both the places. Once you calculate friction, you are ready to write the equations, right? So for the small one, you write, if you see here, it is going upward. So tension minus friction and mg sin theta both are opposite of tension. So tension minus these two forces you have to subtract is mass into acceleration. Simplify, put the values, right? Sin 37 degree, you simplify this. Similarly, if you take the bigger one, capital M, here it is going down, so component of mg is greater mg sin 53 degree minus tension minus friction, because tension and friction are opposite. This is mass into acceleration. So once you get this, simplify this, values are given, you need to do calculations. After that, substitute, calculate. Okay, you will get mass as 4.5. Understood? So that's how we can solve it, right? 4.5, second option is correct. Then let us go to the next question. In the next question, they are saying that there is a coin kept, right, and the table is rotating. So the coin is also rotating with the table. Now coefficient of friction is mu, and the distance from the center, that is radius, they have given us a small r. Okay, angular velocity they are asking, maximum angular velocity. If you rotate faster, at one point it will throw away, it will just move out. So first of all, it is going together, so there must be centripetal force. This centripetal force is provided by friction. So this friction which is acting must be less than equal to maximum friction. Maximum friction is mu time normal, and this friction which is acting must be less than mu time normal. So this is centripetal force m omega square r must be less than equal to mu mg, right? Normal is mg. So omega must be less than equal to root mu g by r. Here capital R is same as radius, small radius. So this is the correct answer, root under mu g by r. That's the maximum value. Okay. So I hope you are understanding that. And let's go to the next question. So this is a question of direct upward machine. Two masses are given, and they are saying that the system acceleration is given as g by r. To direct formula for acceleration, you will apply upward machine m1 minus m2 by m1 plus m2 into g. Just put a is g by 8. So from here this ratio you will get m1 plus m2 by m1 minus m2 is equal to 8. Once you get this, solve this, you will get m1 by m2 is equal to 9 by 7. You can directly do in one step by applying componendo dividendo. Just you can solve 8 divided by 1, so 8 plus 1, 8 minus 1, right? You will get that ratio. Okay. So then next question, let's take. Here they have given that there is a block of 5 kg and there is a force F1 acting, which is this force just required to move upward. Okay, and F2 is the force which is just required to prevent it going down. So there is a difference in the key ideas here. So when you are just trying to just required to move up, that means it has a tendency to move up and your friction is acting backward, right? So other forces you balance. So one thing is that you need to consider this as balanced only. So F1 will balance F plus mg sin theta, just it is balanced. And similarly when you try to prevent it, so it has a tendency to move downward, so friction will act upward. So now this time F2 plus F will balance mg sin theta, or F2 is equal to mg sin theta minus F, right? So once you get this, so they are asking what is F1 minus F2. This is magnitude. Okay, so what we are writing F1 F2 is magnitude only, right? So magnitude F1 minus F2, when you do, you will get 2 times of friction. Friction you calculate separately, mu times normal, substitute the values and calculate. Once you calculate friction, substitute here, that is 5 root 3, that's the correct answer. Okay, so in this way we can work out questions. So I hope you have understood some of these important questions, right? So today we have covered all the questions of Newton's laws of motion. Very important chapter. Lot of applications are there in other chapters as well. So please do go through this topic properly. Thank you for your attention, and we'll see you next time.